So in the last video, we set up the virtual environment with Python, creating another data science package management system, much like the previous video we did Anaconda. So here in VS Code, I'm showing just a README, the logic we're looking for, reviewing historical recessions for overlapping attributes, and then we're going to get into the data that we're going to pull using Python, and then that will be what we start our machine learning on economic data that will forward feed into our stock valuation, then technical analysis at the end. So this is first phase of the larger project. So here we have just overlapping attributes between some of the recessions. So what we're going to do now is go look into what data we can find that is contributing to these recessions that we can capitalize on in the market. So in this screen here, what we're looking at is I pulled in about 12 St. Louis Fed economic data sets that I believe are going to contribute heavily into market recessions, into predicting market recessions, and or just capitalizing on opportunities. So the first one here that I want to look at or talk about is the 10-year to 3-year maturity. So this is kind of a yield curve. So the standard yield curve that most people are probably familiar with is the 10-year to 2-year. So essentially the logic in the 10-year to 2-year is that whenever we have an inverted yield curve, i.e. the graph goes negative, we're going to see a recession within the next 18 months or so. So we can see this play out throughout time. It's almost foolproof, but it's just one thing. So it's not all you should look at. What I found very interesting is we did slightly go negative here in 2019, and then we did have the COVID recession. And as you can see, we are extremely negative in current day. So this is a little worrisome just to take a look at this, given how history has played out. So this one will be pulling in. The next one will be the 10-year to 3-month. So also the same logic. And it was a little bit greater impact here. We can see prior to COVID. So I want these two, absolutely. And then we're going to look at other kind of trends going on here. So it doesn't really matter. I guess I could just work forward. So this is privately owned housing units, so permits. And this was a big one. I guess biggest impact would have been during the 2008 recession. We have this peak, and which occurred at the end of 2005, and then we saw this steady decrease. We saw this once again 2019, and we saw this drop. This was more of a leading indicator, as was in the early 90s. 2000 to 2002 was the dot-com bubble. So this probably wouldn't have played a big role, but it is good to look at the housing. Corporate profits, we'll get into that. I think this was really big during the dot-com bubble burst. When we had so many IPOs, the valuations were through the roof and typical equities and companies, yet profits were actually declining. We saw this again in the financial crisis of 2008. And then we saw this here in the first part of COVID. So these are all leading to canaries that could have told you, hey, to get out of the market. So the next one is national income corporate profits before tax. And so we're here essentially looking at the same thing. Profits are flat. We see this drop. The curve in 2000, right prior to the financial recession, the Great Recession. And then we have a few blends of these. National income. So this was another one. We're seeing a similar trend now among the differences between these profits and income. And then these ones I found really, really interesting. I definitely want to include these. This is all employees in the retail trade. So typically we see this recession, right? And then we bottom out and employees are hired back. And this is repetitive throughout time. So we can date back as far as this data is collected. But what I wanted to look at, or what the thought is, this looks like a very similar pattern to the S&P 500 to a degree. We have this rolling top and then the down. So when we hit these peaks, which are greater than any previous peak, then we see this decline. Now this one here took a few years, but that's why we would use something like this one first. This is the inverted yield curve, which will then lead into this check, which then we get into the next one, which very similar pattern. We have this kind of seasonality. So we have unemployment at an all-time low, and then you have a recession. Then unemployment goes high, comes back down, unemployment's all-time low, recession, back to high, so on and so forth. So these seem to be triggers where I can see seasonality, and we can probably model these. So I have these 12 or 13 that we're going to pull in, and we're going to model them against the S&P 500 and see if we can build up any forecasting models just based on the economic data to start with. And then we'll move on to consumer sentiment, and then we'll get into kind of equity valuation into sectors to find what sectors are most likely to pop. So the very first thing we want to take a look at is, here's the requirements text. So this is just using pip freeze. The primary we'll be using for this is going to be Pandas Data Reader. So Pandas Data Reader gives us access to the St. Louis Fed data, in which we're just going to call the economic data codes in here. So that's going to be the first script we build, and then we'll also use the YF Finance API. And then for our modeling activities, we'll be using scikit-learn, SciPy stats models. And this is all running on Python 3.10.11 as it's compatible with YF Finance. So with that being said, I'm going to go ahead and open a new file, and we'll call this the Fred data. So we're just going to do fred.py. And the first thing we're going to do is start importing our packages. So we're going to import Pandas Data Reader. Just tab over as PDR. The next, we're going to just import pandas as PD, import date time, as we're going to have to define our start and end dates. So the first thing we want to say is we're going to look back on how many recessions. So we have the recession of the early 90s. That was the loans and savings recession. The next one was the dot-com recession. The next one was the Great Recession, the financial crisis of the mortgage-backed securities. Then the next recession that we had, we'll just say the COVID natural disaster. And then we're trying to identify the next one that's going to come. So let's go ahead and pick our start time, and start time, or I guess start date. And start date should be equal to date time, and we'll say we wanted to go right before the loans and savings, so we'll say 1989. Let's do May 1st, and that should be good. Our end date should be, I don't want to go as up to 2-day, but I want to go to the last GDP reporting, which at least in October, because that was a huge ramp and I want to try to predict that. Personally, that's the one I really want to capture. So I'm going to go to 2023. I'm going to go to October, and we'll say 5th, I think, as we're doing monthly. So now let's define our indicators. If I can spell, it's a little late. Okay, so indicators, let's go ahead and we had those 12 on screen. I can go ahead and pull those back over so everyone can see. So over here, what we have, the way we're going to do this is we're going to just give it a name. And I'll probably just name these 10 3-month yield curve. And then this is the code you're looking for. So these are what you're actually going to put in for the code when we call from Pandas Data Reader. So that's how we're going to run this. So let me go to unemployment. So you'll see right here, this UN rate, we could just copy that and put unemployment rate or define it however we'd like. So let's do unemployment. And then we're going to put colon and then quotes, and we'll put the code in just like that. Okay, to save everyone from my painful typing, I went ahead and just put the rest in. So next, let's move on to, now we're going to put these into a data frame here. So let's go to data frames, something, curly brackets, and now we'll just put a for loop to call the names, which we'll just say for name, and then the code and indicator, and we'll say dot items. And then let's go ahead and say data frames. And now we need to call the name. We'll say equals the PDR. And we should be able to get our data. I wonder if this is going to have it here. Get data Fred. Yeah, that'll work. Let's do code. Start date. End date. And that looks good. Now what we need to do is go ahead and concatenate all of these into our data frame. So we're just going to do pd.concat, and let's do data frames. And then let's do axis equals, oops. And then we'll go ahead and just for fun. So we're going to have to put this into a database. So I'm still debating if I want to build MySQL or Postgres, but we'll for now just put these into a CSV just so we can take a look at them. So CSV, and then we'll just call this something like Fred.csv. And let's see if this runs. So it looks like it's trying. This is running to my external hard drive, which in the last video I was setting it up just to test to see how it was going to run. So we'll take a look and see if this thing runs well or how long it takes to load this data and basically what it looks like. Okay, so we can go ahead and just take a look at this. All right, looks like we have everything, and cool, the concatenating brought in our data frame. So here's the names at the top. And then what we can see is on these null values, these are going to be reported on a different rhythm. So we did capture what we can capture for daily. Let's go down. Yep. And then a lot of these are going to be monthly. So we're going to probably have to do something to match the index to the S&P 500. So that'll be our next task. So I'm going to create a new file and then we'll start for the S&P 500.